Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this crash course on hydrogen, and I hope you've enjoyed the first part from this course. So today we will be beginning with lecture 2 from the crash course hydrogen. In lecture number 1 we have already discussed about hydrogen, its discovery, its preparation, its properties, uses, hydrogen economy very importantly, and then we have also discussed about the hydrides, right? So moving further in this lecture, what we are going to discuss today is going to be water, the structure, the properties of water, and then we are also going to discuss in this lecture the hardness of water, what are the causes for hardness, what are the different types of hardness, how we remove those different types of hardness, and then some numericals based upon the degree of hardness of water. So all this we are going to do with the help of some multiple choice questions as we've done previously. In the previous lecture there were 38 questions that we discussed on hydrogen. So this lecture also we are going to do a few multiple choice questions from the previous year papers of JEE Mains, Advanced NEET. Along with that, we will be also putting in questions from the NCERT exemplar book, and also a few questions will be from the various state competitive examination as well, so that we can discuss the topic in complete, right? So the questions, they have been chosen in such a way that we can discuss the whole topic of water with you people today. All right, and all those who have watched my previous lecture, you already know that I have a detailed course on hydrogen, and from my detailed course hydrogen, the topics that we will be discussing are in lecture number 8, 10 and 11. Lecture number 9, 12, 13 and 14 are heavy water and hydrogen peroxide, which we will be discussing in the crash course hydrogen lecture number 3, right? And all the students who have watched that detailed course on hydrogen, you also know that at the end of the lecture I am putting up the lecture review questions, and actually these are those questions which we have put up together in this crash course. So all those who are wanting the answers to their lecture review questions, this is the lecture for you people as well, where you will be getting a detailed answer to your questions as well, right? So let us begin the learning today. So let us begin our learning today with the multiple choice questions. And here the question number 1 to 6, they will be related to water, the structure, the physical and the chemical properties. And this is something that we have discussed in lecture number 8 from the complete course hydrogen. So the complete course hydrogen from us, this is a total of 14 lectures. The first 7 lectures were what we discussed in the previous lecture, that is crash course 1. And in this lecture we will be discussing the topics from lecture number 8 to lecture number 14. So I will just keep on telling you the questions that are going to be related to which lecture. So wherever you are feeling a difficulty, please do go and visit that lecture, right? So question number 1, the high density of water as compared to ice, this is due to hydrogen bonding interactions, dipole induced dipole interaction. This was asked in the All India PMT examination 1997. We have chosen questions from the past 30-35 years just to cover up whatever topics we found that was necessary and very important for you people to remember at this point of time. All right, so the first 3 questions I will be putting them together because I will be doing the discussion together. So the second question is the critical temperature of water. This is higher than that of oxygen because water molecule has fewer electrons than oxygen, 2 covalent bonds of attraction, V-shaped and dipole moment, and this was IIT examination 1997. The next is, which of the following properties of water are not correct? Water is known to be a universal solvent. Hydrogen bonding is present to a large extent in water. There is no hydrogen bonding in the frozen state of water, and frozen water, this is heavier than liquid water, and this is a question which has been asked in the NCERT exemplar book, right? So these are the 3 questions where essentially what we have to discuss is the structure of water. All right, the structure of water, and here where there is going to be some discussion on the physical properties of water. So let us first of all discuss the structure of water. So when we discuss the structure of water, we have to discuss it in the three states of matter, that is the gaseous state, the liquid state, as well as the solid state. So first of all, we will be discussing in the gaseous form. In the gaseous form, the molecules, they are far away from each other. So the structure that we discuss is essentially the structure of the water molecule. And I hope you all know, because this is something very basic that you have studied in the course on chemical bonding. So first of all, we have the lowest structure in front of you. So in the lowest structure, oxygen, this has 6 valence electrons. It requires 2 electrons to complete its octet. Hydrogen has 1 electron. It requires 1 electron to complete its duplet, so that they attain the nearest noble gas configuration. So oxygen is going to form 2 covalent bonds with 2 hydrogen atoms in the water molecule, right? So next we move on to the structure according to the VSEPR theory and the valence bond theory. So here oxygen, this is forming 2 covalent bonds with the hydrogen atoms, and there are 2 lone pair of electrons. So when there are 2 lone pair of electrons, they are going to repel each other more because the electron density in them is more. So because of this repulsion, what is going to happen? The covalent bonds, they are going to come closer to one another, and what we will be seeing is that this is going to have a distorted tetrahedral geometry. sp3 hybridization is what we have for the methane molecule, where all carbon bonds with hydrogen, they are covalent bonds, right? In case of oxygen, we have 2 covalent bonds and 2 lone pair of electrons. So here this angle is 109.5 degrees. For the water molecule, this angle is going to get reduced as the bonds, they're going to come closer to one another to give maximum space to the lone pair of electrons. So the angle, this becomes 104.5 degrees. So this is a sp3 hybridization again, but a distorted tetrahedral geometry. Along with that, the electronegativity value of oxygen is 3.5. Electronegativity value of hydrogen is 2.1. So what we see is that there's going to be a partial negative charge on oxygen, a partial positive charge on hydrogen, because the electron pair, this is going to get pulled towards oxygen, right? And because of this, this bond, this has some dipole moment, and the net molecule also has a dipole moment of 1.84 dpi. This is because of the uh, bent or the V shape of the molecule, right? So now as far as the structure in the gaseous form is concerned, this is it. Next, moving on to the liquid state, where the structures now, they're going to be more important for us. So now, because of the virtue of the polar nature of the water molecule, water in the liquid state as well as in the solid state, this shows hydrogen bonding. So I'm not going to discuss what is hydrogen bonding over here. I assume that you all know that, but because this is something that we have done previously in the courses on chemical bonding as well as in the states of matter, right? So hydrogen bonding, this is a special case of the dipole interaction. And here in the water molecule, what you have to remember is that each oxygen atom, this is capable of forming 2 hydrogen bonds, and 1 hydrogen bond is capable of forming 1 hydrogen bond. So per molecule of water, we can form 4 hydrogen bonds, both in the liquid state as well as in the solid state. Now what the difference between the liquid and the solid state is that in the liquid state, the molecules, they are having more thermal energy. They are moving at a much faster speed as compared as the movement of the water molecules in the solid state. So because of this, the water molecules, when they are showing hydrogen bonding, this is a random hydrogen bonding, and every molecule may not be forming that 4 hydrogen bonds. Okay, so this is what you have to remember, that this water molecules, they are coming from all directions. There's no particular fashion in which these molecules, they are coming closer to one another. But what happens in the solid state is each oxygen of the water molecule, this is going to be surrounded by 4 molecules oxygen in such a way that this is a tetrahedral arrangement. Okay, so if you look at this oxygen, this is going to form one attachment with the other water molecule oxygen through a hydrogen. Okay, so this oxygen is forming a covalent bond with hydrogen, and this hydrogen will be forming further a hydrogen bond with the oxygen. So this is 1, this is 2, this is 3, and this is a two-dimensional representation of a three-dimensional structure of ice. So the fourth is going to go into or outward from the plane. Okay, so this would be a tetrahedral arrangement for the oxygen molecules. One oxygen being surrounded by four oxygen atoms in such a way now that there is a large of empty space in the water molecule in the solid state. So this is ice having a cage-like structure. Okay, and because this is an open cage-like structure for ice, we see that the density of ice, this becomes less than that of water. More spaces they have come, so number of molecules per unit area, that is going to decrease, and hence the number of molecules per unit volume, that will decrease. And when volume, the mass per unit volume, that is going to decrease, what we will be having is that the density, that is going to decrease. Now with the decrease in density, what you have to remember is, number one, that ice, this floats on water because it has less density. Second is, when in winters the lakes, they are going to freeze in the areas where freezing is going to happen, the temperature is going to go below 0 degrees Celsius. That what will happen is that the freezing will start from the top. Okay, from top going towards the inner side. And how does this help the aquatic animals? That is what you have to remember, that first of all, the freezing is on top, so it is going to form a insulation between for the insulation from the outer atmosphere cold weather, right? So the aquatic animals, they can survive in winters because of this. The next thing that you have to remember is that the density of water, this is maximum at 4 degrees Celsius, right? From 0 to 4 degrees Celsius, the bonds, they are breaking. So that is why 4 degrees Celsius, the maximum density, and beyond 4, if we are going to increase the temperature, the thermal energy of the molecules, that increases. So when that increases, well, again, the density starts decreasing. The details you can watch in the course, in the lecture I have already told you, that is lecture number 8. All right. So now let us look at the questions that we have to discuss, the first 3 questions. So now let us look back to the questions that you've already seen. So the high density of water as compared to ice, this is because of hydrogen bonding interactions. So the correct answer is going to be A. The critical temperature of water is higher than that of oxygen because the water molecule, this has dipole moment. So water molecules is polar, so the intermolecular forces of attraction, they are more. Therefore the critical temperature is going to be more, whereas oxygen molecule, this is non-polar, right? So the correct option is going to be the D choice. Which of the following properties of water is are not correct? So I'll be starting from down because this is something that I've already discussed. So frozen water is heavier than liquid water. No, it is not heavier. This is lighter. That is why ice floats on water. There is no hydrogen bonding present in the frozen state. There is hydrogen bonding present. Per molecule, there is going to be 4 hydrogen bonds that are going to be formed, right? Hydrogen bonding is present to a large extent in liquid water. So yes, this is correct. So C and D choices, they are incorrect. Water is known to be a universal solvent. This is not what we have discussed till now. So water is a universal solvent because this can dissolve ionic compounds as well as covalent compounds. Covalent compounds, it is dissolving because of its polar nature. For example, alcohol, this has a OH as the terminal group, right? So oxygen and hydrogen, so that means hydrogen will have a partial positive charge, and therefore this can get attracted to the water molecules by hydrogen bonding. This is very important in the carbohydrate metabolism in the human body. All right, in fact in the animal body we can say. So the next is that water, this is a universal solvent because this can also dissolve the ionic compounds, and this is because of the high dielectric constant value for water. So the high dielectric constant is 80 for water. Water is able to dissolve the ionic compounds in it. How is that? According to the dielectric constant, that water is able to dissolve the ionic compounds, this is something that I've discussed in detail in the lecture. So if you have any doubts, please do visit that lecture. I will not be able to explain everything in detail over here because then it is going to be a complete discussion of the whole chapter only. Now the next question is, which of the following statements about water is false? Water can act as both as an acid as well as a base. There is extensive intramolecular hydrogen bonding in the condensed phase. Ice formed by heavy water, this sinks in normal ice. Water is oxidized to oxygen during photosynthesis. So first of all, let us look at the things that we already know now. So there is extensive intramolecular hydrogen bonding in the condensed phase. No, it is intermolecular. Right, so different molecules, they are exhibiting hydrogen bonding. It is not that hydrogen bonding is is present in the same molecule of water. So difference between intra and intermolecular. Intermolecule is in between different molecules, whereas intra is in one molecule itself. Okay, so this is the statement that is wrong over here. So the rest of the things which I want you to know is that water can act as an acid as well as a base. So water is amphoteric in nature. It can act as an acid as a base. When it is going to react with stronger acids like HCl, it is going to act as a base. Whereas when it is going to be reacting with the bases which are stronger than itself, it is going to act as an acid, right? So this is, I think, very clear to you people. You have done so much of chemistry till class 12th ending, so I hope I do not have to explain you all this. Now the next we have a C choice. So ice formed by heavy water, this is going to sink in normal water. So heavy water is made up of hydrogen, which is deuterium, that is heavy hydrogen. So that would be having a greater mass than normal water. Therefore, which ice will be formed by heavy water, this will be heavier than the normal ice that will be formed by ordinary water. Therefore, this is going to sink in normal water because of the greater mass. Okay, then the next choice is water is oxidized to oxygen during photosynthesis. So the reaction is that carbon dioxide 6 molecules react with 12 water molecules to form glucose C6H12O6 plus 6 water plus 6 O2. So the net reaction would be actually 6 water molecules on the reactant side. So water is going to form oxygen. The oxidation state in water is going to be -2 for oxygen, whereas oxygen on the product side, this is in the elemental form, so this is going to be 0. So -2 to 0, this is oxidation reaction, an increase in oxidation number. So this is also a correct choice. So the correct answer is going to be B choice, that here it is not extensive intramolecular but intermolecular hydrogen bonding that is present. Fifth question, again a chemical property question from water. The hydride ion H negative, this is a stronger base than the hydroxide ion. Which of the following reactions will occur if sodium hydride is dissolved in water? The choices they are given over here, and this is a all India PMT examination 1997 question. So what you have to remember over here are the properties of water with the hydrides, and also we can revise over here the reactions of water with the carbides, the nitrides and the phosphides. Let us first of all see, as in the question we have a hydride example. So calcium hydride, when this will be reacting with water, what we will be getting is calcium hydroxide plus hydrogen will be evolved. These are the reactions that you have discussed while we were preparing hydrogen. All right, now these all hydrides, this means that this will be a H negative. H negative on reaction with water is forming a OH negative and hydrogen is evolved. So the correct option, I hope now this is clear, that this is the B choice. Right, now let us quickly look at the reactions of water with the carbides, nitrides and the phosphides also, because these are very important and they can also come in the examination. So calcium carbide, when this will be reacting with water, we will be getting calcium hydroxide and ethyne. So what we are seeing is a hydroxide is being formed, and along with that the metal and metal hydride is being formed. All right, so let us see further. Aluminium carbide plus water forming aluminium hydroxide plus methane. Magnesium nitride plus water forming magnesium hydroxide and ammonia. Calcium phosphide plus water forming calcium hydroxide and phosphine, pH 3. All right, so all of these compounds, they are what? They are the hydrides of these elements, and along with that the hydroxide is formed. So this is how you can remember these reactions. The next question is that when a substance A, this reacts with water, it produces a combustible gas B and a solution of substance C in water. When another substance D, this reacts with a solution C, it produces the same gas B on warming, but D can produce gas B on reaction with dilute H2SO4 at room temperature. A imparts a deep golden yellow color to the smokeless flame of Bunsen burner A, B, C, D respectively are. Now, if you remember from your study of practical chemistry, or if you remember your S block elements, there you have studied what is the color imparted by the metal salt to the flame. So there you must be remembering that sodium is the one which gives a deep golden yellow color to the Bunsen burner flame. Okay, so the correct option is going to be A option. There is no other choice that you have to think of, but let us just check what is all given to us, whether this is correct or not. Fine. And there's also a possibility that you do not remember the color of the flame. So first of all, we have substance A which reacts with water. So sodium is reacting with water. It is going to produce NaOH and hydrogen. So hydrogen is the combustible gas B that is being produced, and NaOH is the substance C in water that is being produced. So aqueous solution of sodium hydroxide. Right. Now another substance D, this is reacting with NaOH to again produce B, that is hydrogen. So it is going to be, according to the question, zinc plus NaOH forming sodium zincate and hydrogen is going to be evolved. And also zinc can react with the dilute H2SO4. It is an amphoteric element. So amphoteric elements, they react both with acids as well as bases to produce the corresponding salt, and hydrogen is evolved. So this is something that we've already discussed while we were discussing the preparation of hydrogen. All the metals which are going to be above hydrogen in the reactivity series, they react with water to produce the corresponding hydroxide or oxide, and hydrogen is evolved. Right. So I hope this is something that you will remember always. This is very, very important. Also the metal oxides, they also react with water to produce the corresponding hydroxide. Okay. And the non-metal oxides, also they are going to produce acidic oxides. So the non-metallic oxides, they are the acidic oxides. So when they are going to react with water, they will be producing the corresponding acid. For example, if we have carbon dioxide will be reacting with water to produce carbonic acid. So this is something again that you have to remember regarding the chemical properties of water. The next topic that we are going to discuss is the hardness of water. So this is going to be my lecture number 10 from the course hydrogen, if you want to have a look at all the details of the topic. All right. Now, why is the water hard? The water is hard. So first of all, let us discuss why, what is meaning of the hardness of water. So it is going to be hard when it is not going to lather with soap. And what is the cause of this hardness? It is the presence of some salts of calcium and magnesium which make the water hard. So what are those salts? It is going to be either the bicarbonates of calcium or magnesium, or the sulfates or the chlorides of calcium and magnesium which make the water hard. And on the basis of this, we have two types of hardness. One is going to be temporary hardness and one is going to be permanent hardness. So the temporary hardness is because of the presence of bicarbonates of calcium and magnesium dissolved in water. And because it is bicarbonate, so we also call it as carbonate hardness of water. And why it is called temporary hardness? This is because we can remove this hardness by boiling alone. And the permanent hardness, this we cannot remove by boiling alone, so we call it as permanent hardness. All right. And this hardness is because of the presence of chlorides and sulfates of calcium and magnesium, and therefore this is also called as the non-carbonate hardness of water. All right. What is important for you people is how we are removing these two types of hardness. Right. So the temporary hardness we can remove by two methods. One is going to be boiling and the other is going to be adding slake-like, that is a suspension of calcium hydroxide. Whereas the permanent hardness, this can be removed by adding washing soda, exchange of ions, which is called as the ion exchange method, and Calgon's method, and the synthetic resin method. So you should be knowing the details of these. A few I will be able to cover up in the questions that you will be seeing now, but if there is something that you are actually lacking behind, all these things, they should be clear in your mind. All right, so you should have a complete knowledge. So in case while looking at the questions you feel that something is lacking, please do visit the lecture number 10 as I have told you. So we will be, I have discussed everything in detail over there. So now let us see the questions related to the hardness of water, and please remember that this is an important topic. Many questions they are coming from the hardness of water. So please do this topic very thoroughly. All right. So the first question is that the temporary hardness of water, this is due to sodium sulfate, sodium chloride, calcium bicarbonate, calcium chloride. So what do you have to remember? What is the cause of temporary hardness and what is the cause of permanent hardness? So temporary hardness, this is because of the bicarbonates of calcium and magnesium. So the correct option over here is going to be the C choice, and this is a JEE Mains 2019 January question. All right. And the permanent hardness is going to be because of calcium and magnesium sulfate and chloride. Please do remember this. This is something very important and very simple to remember as well. The next question is the method used to remove the temporary hardness of water. This is Calgon's method, Clark's method, ion exchange method, synthetic resin method. So we have just listed the methods and the differences. So the Clark's method is the one which we use to remove the temporary hardness of water, along with boiling, which can also remove the temporary hardness of water. All these three methods, they are going to be used for removing the permanent hardness of water. All right. So the Clark's method, I will be just now discussing this on the next slide when there is going to be one more question related to the Clark's method. All right. So what are the details of this? We will be briefly discussing on the next slide. So the correct option is going to be here. B option, and this is a NEET 2019 examination question. The next question is the temporary hardness of water sample. This is due to a compound X. Boiling the sample converts the compound X into Y. X and Y, they are respectively, and the choices they are given to us, right? So the temporary hardness of water, this is due to a compound X. So this is what probability, what it can be. It can be either a calcium bicarbonate or it can be a magnesium bicarbonate. So let us look first of all at X only. So we have magnesium bicarbonate, we have calcium bicarbonate, we have magnesium bicarbonate, we have calcium bicarbonate. So this is not going to help us because all these four options, they are going to be correct as far as X is concerned. Now boiling the sample, this converts the compound X into Y. On boiling, calcium carbonate, calcium bicarbonate, this will get converted to calcium carbonate. If I write down the reactions for you, so it is going to be calcium bicarbonate. This on boiling, this is going to get converted into calcium carbonate. Water and carbon dioxide, you can write that down as well, and you can balance the reaction. All right. And it is, if it is going to be magnesium bicarbonate, I'll just write magnesium and bicarbonate is this way. Okay. And this is going to get converted into magnesium hydroxide, not into magnesium carbonate. This is what you have to remember. And here what you have to remember very importantly is that the solubility product of magnesium carbonate, this is greater than that of magnesium hydroxide, and therefore it is not magnesium carbonate which forms a precipitate, it is magnesium hydroxide which forms a precipitate. Both calcium carbonate as well as magnesium hydroxide, they are going to form precipitates. We can remove these precipitates by filtration, and hence the water is going to get free from the hardness. This is something that you have to remember. Why I am laying a lot of stress on this is because in the NCERT textbook what is given is that the solubility product of magnesium hydroxide is greater than that of magnesium carbonate. Okay, so please do correct that it is the solubility product of magnesium carbonate that is more than that of magnesium hydroxide. That is why magnesium carbonate, this gets dissolved in water, whereas magnesium hydroxide, the precipitates will be formed. Please do remember this. This is very important for you to remember. All right. So the products now, if you look at them now, what you can see is that here it is magnesium carbonate. So magnesium bicarbonate on heating is going to get converted into magnesium hydroxide. So the C option, this seems correct because here it is getting correct formed into magnesium hydroxide. Calcium bicarbonate is not going to get converted into calcium oxide, and calcium bicarbonate is not going to get converted into calcium hydroxide. So the correct option, it is going to be what? It is going to be C option, and this is a question which was asked in the JEE's April 2019 examination. So please do look at these all questions coming in the January, April JEE examination as well as in the NEET examination. So this is a very important topic. Please do not miss it. Okay. So the next question is water softening by Clark's process. This uses calcium bicarbonate, sodium bicarbonate, potash alum, calcium hydroxide, sodium meta-aluminate. This is a question which was asked in the Kerala PET 2003, again a entrance examination for the engineering students. All right. So the correct option is already seen over here, that this is D choice, and that is that in the softening by Clark's process we use calcium hydroxide. So we use over here slake lime, that is a suspension of calcium hydroxide. All right. Now let us look at the reactions what are going to happen over here. So by adding slake lime by Clark's method, what we do is that calcium hydroxide, this is going to get reacted with calcium bicarbonate present in the hard water, and calcium carbonate and water will be formed. So calcium carbonate is going to form a white precipitate, so which we can remove by filtration. Similarly, when magnesium bicarbonate, this is going to react with calcium hydroxide, it will be forming calcium carbonate. Magnesium hydroxide and water both are going to form white precipitate, so this we can remove by filtration. Okay. Now one thing that you have to remember over here is that we have to add a measured amount of this slake lime. If we add the excess of this, what will be happening is that calcium hydroxide, this can react with the carbon dioxide of the air and form calcium bicarbonate again. So this will again become soluble in water, and the water, rather than becoming soft water, it will become hard water again. Okay, so we have to add a measurable quantity of the slake lime. That is what we have as the Clark's process. So the next question is polyphosphates. They are used as water softening agents because they form soluble complexes with anionic species. They precipitate the anionic species. They form soluble complexes with the cationic species. They precipitate the cationic species. And a question asked for the IIT examination 2002. Now, do you all remember where did you study about polyphosphates? Right? I hope you all remember the word calgon. So calgon was the trade name for sodium hexametaphosphate. The chemical formula for which is Na2Na4PO3 6 times. So this is what stands for hexametaphosphate, and we have sodium along with that. So if you just total up these, you can also write the formula as Na6PO3 whole 6, or you can also write it as Na6P6O18. So these are the ways the formula for the compound can be written. So this is sodium hexametaphosphate, and we use it for the removal of permanent hardness of water. Right? So how do we do that? For example, if we have calcium chloride, this is going to form a complex with the calcium ions. All right, and the sodium ions, they're going to get set free, and what we will be getting a water soluble complex. Okay, so what has happened over here? The calgon, this has formed a complex with the cation of the hard water, right? So the choice that is going to be correct, I hope now you can understand that it is going to be the C choice. It forms soluble complexes with the cationic species. Let us see one more reaction where we have magnesium ions. So this is magnesium sulfate. The permanent hardness is either because of calcium chloride or calcium sulfate, magnesium chloride or magnesium sulfate. So here also you can see that the magnesium ions, they have gone into the complex, and therefore they are not free, right? So calcium ions and magnesium ions, they are rendered ineffective due to the formation of a water soluble complex, and this is known as sequestration. Okay, so the correct option here is going to be C option. This is how we are treating the hard water. Let us see one more question. When zeolite hydrated sodium aluminium silicate, this is treated with hard water, the Na ions, they are exchanged with the H ions, calcium ions, sulfate ions, magnesium ions, and the question JE 1990. Right now, this zeolite, which is hydrated sodium aluminium silicate, this also you should remember what is zeolite. Zeolite is also called as permuted. Right, this is a very porous compound in which the sodium ions, they are very loosely held. When the hot water is going to pass through the pores of the zeolite, what will happen is that the sodium ions, they will get exchanged with the calcium ions and the magnesium ions of the hot water. Right, so what we will be having is sodium ions out and calcium ions and magnesium ions forming a compound with the zeolite now. Okay, so the correct option over here is going to be B option and D option. Now, one thing more that you can remember about the zeolite or the permuted is that after some time that the sodium ions, they will just get removed and every sodium ion will get replaced by calcium ions and magnesium ions. So we will require a replenishing of the sodium ions. So what we will be doing is we will be just passing the zeolite through the aqueous solution of sodium chloride, where the calcium ions and magnesium ions, they will get replaced back by the sodium ions, and that water, that is the aqueous solution of sodium chloride, that is obviously containing water. So now that will be containing calcium ions and magnesium ions, and that you can just throw it off as the wastewater. Fine. Now, another thing that you have to remember is that these are two ways by which we have treated now the permanent hardness of water. There are two more ways by which we can remove the permanent hardness of water. One is going to be synthetic resins. Synthetic resins, they are just like zeolites. Their ions, they are exchanged. Okay, in zeolite we have an inorganic compound. In the synthetic resins we have organic compounds. They are big molecular massed polymers. Okay, and in that we have two types of synthetic resins. You can have the details from the NCERT textbook or from my lecture, wherever you want to. But in that we have two types of resins. One are going to be the cation resins and one are going to be the anion resins. So in the synthetic resins, what we will be doing is the cationic resins, they will be exchanging H ions with the calcium ions and the magnesium ions, and the anionic resins, they will be exchanging OH ions with the sulfate ions and the chloride ions. So what we will be getting is all the hardness causing salts, either they are calcium ions or magnesium ions, or they are bicarbonates, they are the chloride ions, the sulfate ions, every hardness causing ion that will be getting removed. Okay, so the details you can watch in my lecture, or you can read from the NCERT textbook. Another one thing that is left behind is that we can also remove the permanent hardness by the addition of washing soda, that is sodium carbonate. So when sodium carbonate, this is going to react with the calcium ions, it will be forming calcium carbonate. When it will be reacting with the magnesium ions, it will be forming magnesium carbonate, again which can be removed. And if we want to remove both the permanent hardness as well as the temporary hardness, what we will be doing, we will be adding washing soda along with lime. Right, so the lime will be removing the temporary hardness, and the washing soda, it will be removing the permanent hardness causing salts. And in total, what we call that process is the soda lime process. Okay, so the details, if you want, again you can watch it in my lecture or you can read them from the NCERT textbook. So the next topic that we will be discussing is hard water, some numerical problems. All right, and this is my course lecture number 11. And here what you have to do is essentially learn one term, that is degree of hardness of water. So what is degree of hardness of water? This is the number of parts of calcium carbonate or magnesium carbonate equivalent to the various calcium and magnesium salts present in million parts, that is 10 power 6 parts of water by mass. This is expressed in parts per million. Right, so we have various calcium and magnesium hardness causing salts. What we will be doing is their amount, we will be expressing it in terms of calcium carbonate and magnesium carbonate. How you will be seeing with two examples that I have taken in this lecture. One is a JEE Mains 2020 question and one is a JEE Mains 2019 question. If you want to practice more, well, you can go back to my lecture number 11 again, and you can have a more practice also. Right, so the formula for degree of hardness of water is mass of calcium carbonate over mass of water into 10 power 6 ppm. So let us see those two questions. So let us see a question from the JEE Mains January 2020 examination. Determine the degree of hardness in terms of the ppm of calcium carbonate of 10 power minus 3 molar magnesium sulfate solution. Right. So what is given to us is that we have hard water in which the hardness causing salt is magnesium sulfate, and we want to express the hardness because of magnesium sulfate in terms of calcium carbonate. Alright, so how are we going to proceed? So first of all, what is given to us is 10 power minus 3 molar magnesium sulfate solution, which means 10 power minus 3 moles of magnesium sulfate, they are present per liter of the solution. And because the mass of the solute is going to be very much less as compared to that of the solvent, we can say that it is going to be 10 power minus 3 moles of magnesium sulfate present per liter of water. Alright, now the number of moles of magnesium sulfate, this will be equal to mass of magnesium sulfate over molar mass of magnesium sulfate. What is given to us as number of moles is 10 power minus 3 moles. So 10 power minus 3 moles of magnesium sulfate will be equal to mass of magnesium sulfate over molar mass, which is 120. So the mass of magnesium sulfate that we have in this 1 liter of water is 120 into 10 power minus 3 grams. Perfectly fine till here. Good. Now, the volume of water, this is going to be 1 liter. 1 liter of water, and 1 liter of water is going to be equivalent to a mass of 1 kilograms, because the density of water, this is 1 gram per centimeter cube. So I hope you all people know how are you going to convert that density of 1 gram per centimeter cube in terms of 1 kilogram and liter. Okay, so if you do not, okay, let us do that as well. Right, so density is going to be equal to mass per unit volume, and what is for water, what we have is 1 gram per 1 centimeter cube of the volume. So 1 centimeter cube is 1 ml. Okay, so if I have 1000 ml of water, which is 1 liter, so how many grams of water I will be having? 1000 grams. Right, so for 1 liter of water, the mass is going to be equivalent to 1 kilogram. Perfectly fine. Now just let me clear this out. Right, so now what you have to do is you have to express the hardness of magnesium sulfate in terms of calcium carbonate. So what we will be doing is we will be equating the number of equivalents of calcium carbonate to that of magnesium sulfate. Right, so the number of equivalents of calcium carbonate, this is equal to the number of equivalents of magnesium sulfate, which means weight of calcium carbonate over equivalent weight of calcium carbonate, this will be equal to the weight of magnesium sulfate over the equivalent weight of magnesium sulfate. Right, weight of calcium carbonate is what we have to find out. Equivalent weight of calcium carbonate will be equal to the molar mass divided by the Z factor, and Z factor for calcium is going to be +2. Right, so it is Z factor is going to be 2. Right, similarly for carbonate also it is -2, so the Z factor is going to be 2. So the equivalent weight for calcium carbonate, this is going to be 2. In case you do not know how we apply the equivalent concept, you can go back to my lectures from the course on some basic concepts of chemistry. There I have tried to explain in a very simple way the equivalent concept, that is going to be very helpful even if you do not know the equivalent concept till now. Alright, so you can do that. So the equivalent weight of calcium carbonate is going to be the molar mass, that is 100, divided by the Z factor, that is 2. So the 2 is going to go into the numerator. So x by 100 into 2, this will be equal to the equivalent, the weight of magnesium sulfate, which we found out, we have calculated that this is 120 into 10 power minus 3 gram. Divide this by the molar mass 120 and the Z factor, that is going to go into the numerator. This is going to be again 2 for magnesium sulfate as well. Fine. Now if you are going to solve this, the value of x, that is the weight of calcium carbonate, is going to be 10 power minus 1 gram, that is 0.1 gram. So the mass of calcium carbonate, this is 0.1 gram. mass of water is 1 kg or 1000 grams. So the hardness of water is going to be the mass of calcium carbonate over mass of water into 10 power 6, because we express it in ppm. So we have 0.1 divided by 10 power 3 into 10 power 6. So this will come up to 100 ppm. So this is going to be the answer to this question. The next question is that 100 ml of a water sample, this contains 0.81 grams of calcium bicarbonate and 0.73 grams of magnesium bicarbonate. The hardness of this sample, this has to be expressed in the terms of the equivalence of calcium carbonate again, the molar mass of calcium bicarbonate and the molar mass of magnesium bicarbonate. This is given to you. So now instead of magnesium sulfate, what we have is calcium bicarbonate and magnesium bicarbonate causing hardness of water, and we are to express this again in terms of calcium carbonate. So again what we will be doing is the expressing of calcium bicarbonate and magnesium bicarbonate, the number of equivalents being equal to that of calcium carbonate. So let us do again the question. The choices they are given to us as 10,000 ppm, 1000 ppm, 5000 ppm, 100 ppm, and this was the question which was asked in the JEE Mains January 2019 examination. Now the number of equivalents of calcium carbonate, this will be equal to the number of equivalents of calcium bicarbonate and the number of equivalents of magnesium bicarbonate. So both of these we have to convert them in the equivalents of calcium carbonate. So for calcium carbonate, the mass divided by the equivalent mass, which is going to be molar mass divided by the Z factor. So 100 divided by 2, and 2 comes into the numerator. Similarly for calcium bicarbonate, it is going to be, the mass is given to us as 0.81 gram. So 0.81 divided by 162, which is the molar mass of calcium bicarbonate. Again the Z factor is going to be 2, so multiply by 2. Right? Magnesium bicarbonate 0.73, the mass that is given to us, divided by 146 into 2. So when you're going to solve this, you will be getting the weight of calcium carbonate to be 1 gram. Okay. Now the volume of water given to us is 100 ml. The mass of water, therefore this will come up to 100 grams, the density being 1 gram per centimeter cube or 1 gram per ml. So the hardness is going to be 1 divided by 100 into 10 power 6. So this will come up as 10,000 ppm, and therefore the answer is going to be A choice. So that would be all for this lecture. In the next lecture, we will be discussing with MCQs again, heavy water and hydrogen peroxide. And in fact, hydrogen peroxide, many questions, they are coming in the examination. So please be with me for the next lecture. See you again. Have a nice day. God bless you.